Hello dear students. In this video, we will see how to create a stack using array. Just in the previous video, I explained what do you mean by declaring a stack as a structure. This structure, stack, which I am marking, contains two things. It contains array of fixed size and an integer counter top. Now let's have a look at main before we see any operations like push or pop. Because after all, execution of the program will start with main, and we have declared some extra variables ch, x, z and so on, which will be helpful later on. But main sentence over here, or the major line, is struct stack s. You read this as s is a variable of type stack, just as you read this as this x as x is a variable of type int. Like that, s here is a variable of type stack. So if s is a variable of type stack, then s will be definitely a big box. And this box is going to contain two things: array of fixed size and a counter called top. Because anything which is of type stack will be a stack. And stack has two things, as you saw from our declaration. Any stack, this can be read as any stack will always have array of fixed size and a counter called top. So what if I would have written a line like this: struct stack s comma p comma q. What does that mean? S is a variable, p is a variable, and q is also a variable. All are variables of type stack. That means in the same memory we are going to have p as a big box. This is the structure stack, which will contain the array a and a counter called top. And what about q? Q is also a structure stack which contains an array of fixed size and a pointer called or counter called top. So you can create three stacks in the memory by using that structure called stack. And now you can individually push or pop values from this stack, or individually push or pop values from this stack, and same can be done on this stack. That's the advantage of declaring a structure. Once you have declared a structure such as stack, you can create n number of copies or n number of variables of that type. But in this program, we have created only one stack. We just want to demonstrate how to create a stack, how to do operations. But you can declare as many stacks as you need. So what is S? S is a variable. This S is a variable of type stack. So S is going to now contain array A of size 5. Remember, the size constant declared was having a value 5, and the index s goes from 0 to 4. But this s will have a variable called top also, where top will tell us which is the topmost element currently stored in the stack. Now have a look at this line: s dot top equal to -1. The top member, this member of s, is initialized as -1. This is such an important statement. Just don't miss out this, because first we want to tell that nothing is there in the stack. Stack is empty. We want to tell our program that even 0th element is not booked. It is vacant. That means top should be below 0, isn't it? And below 0 is nothing but -1. This line is called initialization of the stack. And this is declaration, creating a new stack. Struct stack S. Now all the things are ready, by the way. We have an empty stack and we have top equal to -1 in that stack. And we are ready to push some values in the stack. So this is a menu driven main, in which if the user enters the choice as 1 in the switch statement, as you see, If the choice is 1, then we are going to ask that user what is the value you want to push or integer you want to push, and we are going to take that integer in X in using scanf. So let's say 10 is entered by the user. So what is our plan is we want to push this value 10 in the stack, and here goes the call. This is the call to push. So main is invoking push function, but notice push has sent address of that big box. Address of S has been passed and the value of X, which is 10, has been passed. This is exactly coinciding with our discussion on stack using linked list. I repeat, these fundamentals on passing the address of the stack were learned in stack using linked list. Anyway, so push function has been called. Let's go to push function now and let's see what is the code written here. Here is the code, void push. Well, before we run this void push, I will draw a picture again. This is the stack, correct? This is S. It has array A from 0, 1, 2, 3, 4th place, right? This is the array we are having. And we have top variable as -1. Remember, main has initialized s dot top to -1. What are we passing to this push function? Check the first parameter. Recall we have passed address of S. Address of S means whatever is the begin address, whatever is the begin address will be stored by a special pointer called P. Now P was not declared earlier. P was not there in the memory. Suddenly P captures the address of S. So P points to S. Correct or not? Here asterisk P is a pointer, and what is this pointer storing? Address of S. So whenever a pointer stores address of some variable, then that pointer points to that variable, isn't it? And this X which I am underlining is after all 10 because we want to push 10. Now in this code, we are going to refer top not as s dot top. Actually, S is the big box in which top variable is there. So if you want to refer top, you will be writing s dot top, but that's not allowed here. We will be writing p arrow top. Please try to understand this. Now p arrow, you just wait and watch p arrow. Check this arrow. P arrow will take us to the box, and this box contains top. So p arrow top is same as s dot top. I hope you are understanding. But why isn't s dot top allowed in this function? Due to the same reason which I explained in the linked list program. This big box S has been declared in the main, and only main has ability to use S. But beyond main, if you try to access the variable S, you will get an error. Such variable is not defined, it will complain. That means you are passing the address, copying the address in the pointer P, and now P handles S. P will handle S because P knows where S stays in the memory. It's as if that you know that everything about S via P, isn't it? So it's like knocking the door. P arrow top will allow you to use S. And what about this notation? Are you understanding? P arrow A. P arrow A. Come on, A is the array. And then if I write square bracket, let's say square bracket, correct? 2. Then what am I doing? I am accessing second element of the array stored in the stack. I hope you got this much. So I think we are fully equipped to see how the push function is going to execute. Let us execute this for the first time where address of S has gone in P and X is 10. Here is the empty stack with the array holding absolutely no values, 0, 1, 2, 3. Yeah, 0 to 4 locations. This is the array, and top is -1. And this entire box is S. S is the stack. But listen, we have passed the address of S. And address of S has got copied in the pointer P, so P points to S. Okay, run this code with me now. First things first, we are going to check, is there any room in the stack? You know what? The array has fixed size. You know that, isn't it? Like this array has only 5 elements. What if you have pushed 5 elements and now you are about to push 6th element? Come on, the array can hold only 5 elements. And what if you try to push the 6th element? There is no room for it. There is no element pending where you can store that 6th element. In such case, we call stack has overflown and there is no chance to push any more new value. How is that stack overflow checked? We will simply ask, is PRO top? Now listen, PRO top right now is -1. You know that top is -1. We simply ask, is it equal to size -1? Recall size was 5 in our example, -1. So we are asking, has top reached this value? And it isn't. This is false, isn't it? So it's not overflown yet. So we will execute the else portion. I hope you are understanding. So in the else, we are doing two statements. These are so simple. We are increasing top by 1. So top which was -1 will now become 0 because of top plus plus. And the value 10, remember x is 10, is stored in the array A. Observe, A square bracket is equal to x has been written. So 10 is stored in the array at which location? PRO top. But PRO top is right now 0. So this square bracket here is after all 0. That means this comes out to be A0. 0th element of A should store 10. And that's it. That is the end of else. And that is the end of push. Just check it out again. I'll just clean up a few things. What if we call the same push function? Let's call the same push function for pushing 20. So again, P is storing address of S, correct? Now let's ask, is there any room in the stack? What is PRO top now? Be careful, PRO top is 0, correct? Because 0th element here I am marking is the topmost, 10 is the topmost. Is it equal to size -1, which is 5 minus 1? No, it isn't. So there is lot of room in the stack. So if S falls and we land up in else where we will increase top by 1. I hope you are getting an idea. This top, which is 0, I am marking here, top is 0, has been simply increased by 1. Because now, whatever you are pushing, like 20, will sit on top of 10. So top, which was 0, let's strike it out, becomes 1. Top is 1. And now, look at this line which I am underlining. X is 20. Then 20 will be stored by the array A. But which location? In the square bracket, we have written PRO top, and PRO top, just observe, is 1 right now. So A1 becomes 20. That's right, A1 becomes 20. And that's it. After that, the push function ends. Let me write it neatly. So top now is 1. Don't you see a perfect stack here? Where this stack was initially empty, top was -1. Then we pushed 10, then we pushed 20. So after pushing 10 and 20, obviously top should be 1. Okay, what will happen if you call the push function once again for a value 30? It's understood that when you try to push 30 in the stack, first top will increase by 1. Check this line, check this line. Top plus plus. So top, which was 1, will now become 2. And here at this line, 30 is going to go in the array. But which location? Second location of the array. So 30 will be stored here. And this goes on. You can keep calling push all day. But actually, after some time, push function is going to reject the values. It will say that I can't store the values anymore. Let's see how. Suppose you have called push again for pushing 40, and then you have also pushed 50. So top is going to be 4 now. I'll just erase this value. Top is going to be 4. Obviously, because 50, the topmost, has been stored at fourth place. Now listen, this array is full now. There is no room for a new value. And what if you call this push function for pushing 60? You want to add one more value, 60, in this stack. But then first we have put a if statement here so carefully, where we ask what is p arrow top. Just check p arrow top is 4. And is it equal to size minus 1? Size minus 1 is 5 minus 1, which is 4. So top is already at the topmost location of the array, and you can't increase it further. So we will shout stack overflow, and we will not go to else, and we will not proceed by pushing any new value. Now, however number of times you call this push function, it is always going to shout stack overflow, because top has reached 4 and it is equal to size minus 1. So this is how you push the value in the stack. If somebody asks me how big is the push function, my answer would be, technically speaking, push is only 2 lines long. Yes, push is hardly 2 statements. What is summary of push? Summary of push is that wherever this variable top is, some values have been stored. This is the topmost, and you want to push a new value, then you simply have to increase this top. So top plus plus, and then in the array A at the topmost place, you have to store X. So the new value will go at this topmost place. These 2 lines are the summary of the push function. I hope you have understood all the operations about push. When we come back in the next video, we will see two functions, empty and pop. How do you remove a value from a stack using array? Thank you very much.